Okay, in this section, we're going to start learning about something called permutations and combinations. Um, there are two different ways of describing sort of how we arrange things and how we select things. So we're going to learn about what they mean and how to compute them, and then how they will get into in the next couple sections how they apply in probability settings. So first of all, a permutation, maybe you've heard the word permutation, is simply an arrangement of objects in a specified order. So you should think about permutation as arrangement, okay? And what I'm going to add here is what I'll emphasize throughout our unit, and what you would want to associate to permutations in general is permutations are arrangements, so order matters. That's the key distinction that's going to come up between a permutation and a combination. A permutation is an arrangement of things, so order is important. We'll see a combination is just a collection of the things, so order doesn't matter. So let's see a situation where we use permutations. 4 students are scheduled to give a presentation to the class. The possible orders in which they represent a permutation, right? The orders in which they represent are different arrangements. That's a permutation. So let's think about the different possible outcomes here. The first presentation, there are 4 different people who might present in that first spot. So there's 4 different outcomes there. The second position, there'd be 3 people available. Once the first person presents, there's only 3 people left for the second spot. So at this point, there are 12 different ways that the first 2 people could have presented. For the third spot, there's only 2 students remaining. So there's going to be 24 different ways for the first 3 students to present. And in the last position, there's only 1 person left. So that actually doesn't change our total number of outcomes. It means there will be a total of 24 possible ways that these students could present. Okay. So symbolically, we're going to talk about permutations here. Let me we'll talk about permutations with this big letter P. Okay, so we have 4 things, and we're going to choose 4 of them. We'll say 4 permutations of 4, or 4p4. So you could say 4 permutations of 4, or 4p4 is a perfectly good way to read that. Okay, and it means we had 4 objects, and we chose 4 of them in a particular order. Okay, so quickly we have to interject something before we learn how to compute permutations. We have to interject on factorials. We've mentioned factorials, I think, maybe briefly in the past, but the idea of a factorial is if we have n factorial, this exclamation point represents the factorial operation, and it means take whatever that integer is, multiply it by 1 less than that integer, multiply it by 1 less than that, and just keep decreasing by 1 integer until we get all the way down to 3 times 2 times 1 at the end, right? Okay, this is n factorial. That's what the computation means, what the operation means. It's important that you can do that in a calculator. So you could do that in the TI Inspire, simply following these directions. I'll show you real quick. In the Inspire, it's under Menu, Probability, and right there at the top, Permutations, whatever your number is. So if we wanted to do 4 permutations, which is the one we just did, 4 times 3 times 2 times 1, we get 24. So Menu, Probability, Permutations. If you have a scientific calculator, maybe you have one that looks something like this one. It's typically going to be, there's going to be some sort of button that says PRB, probability. You might have a button that says NCR and NPR. So we'll see different possibilities for your calculator, but if you have this PRB button, it's going to be right there under the choice 3. And so you can do 3, and again, 4 probability factorial, 4 factorial would be 24. Okay, so your scientific calculator might be a little bit different. For any of these things that I show you on a scientific calculator, if yours is different and you want to know how to do it, feel free to send me a screenshot or a picture of your calculator, and I might be able to just tell you what buttons you need to find. If you can Google it on your own if you want, or we could meet in Teams if you really wanted some help, and you can show me your calculator, and I can try to walk you through if you're having trouble doing any of these operations on a calculator. So anyhow, coming back to that, the reason we learned about factorials is because, if you notice, 4p4 is the way that we can arrange 4 objects, and we saw that that's computed as just 4 times 3 times 2 times 1, or 4 factorial. So we can say that in general, for any positive integer n, the number of arrangements of n objects taken n at a time, that would be n p n, so 4p4, 6p6, whatever, is equal to whatever that integer is, factorial. So here's a key formula. npn, when you select the same number of objects as you have, is equal to n factorial. So let's look at one example that we actually mentioned in the last video. There are 9 players in the baseball team starting lineup, right? You already know who's starting. You put the rest of the guys on the bench. How many different batting orders of 9 players can be made? Well, we know that'd be 9 for the first slot times 8 for the second slot times 7 for the third slot, all the way down to 2, and only 1 option for the last slot in the lineup, which we now know is called 9 factorial, right? We also could have thought of it as we have 9 players. We're going to arrange them. Big P means permutations or arrangements. We've got 9 players. We're going to arrange all 9 of them in particular orders, and we get, what was it, 362,000 or something like that. Let's go ahead and do it in our calculator to see. It is going to be 9 factorial, which is 362,880. So we have 362,880 different ways to write the batting order, and that is equivalent to 9p9, or 9 factorial. Okay, and we'll keep studying factorials and learn about combinations here in the next couple of videos.